the last video just cut off as I was saying we're comparing what we've got here, a gradient of minus a half x, to what is here, which is minus x over 2, which is the same thing. Next, we need to find the y-intercept. We don't know the y-intercept explicitly here, so we'll use this point 2, 0, substitute it in here and find c. So we know that our normal goes through the point 2, 0, which means that when y is 0, x is 2. And rearranging that, we get c is 1. So now let's just write out our equation again. We get y equals minus a half x plus 1, which is exactly the same as what's shown there, but I would do another line of working just to write that down. Because I'm writing on the same sheet, it's getting a bit cramped, so I'm not going to write that down. Okay, the line L intersects the graph of f at another point Q shown in the following diagram. Find the x-coordinate of Q. All right, we can use a calculator to do this, or we can solve it by hand. So we know the equation of f is x squared minus 2x. We know the equation of this, it's 1 minus x over 2. So we can multiply up to get a quadratic. So I'm going to multiply everything up by 2. 2 minus x, bring everything over to one side to get it in how we'd normally see a quadratic. So I'm going to add on x there. I take off the 2. This factorizes nicely. 2x squared minus 3x minus 2 factorizes to 2x plus 1 and x minus 1. So my solutions there are x equals 1 or x equals minus a half, which doesn't make sense because I know one of my answers should be 2, so just recheck this. This should be x minus 2. So x equals 2, that's P. X equals minus half, now that is Q. All right. You could also put this onto a graphical calculator to solve it. So let's just go through how we do that. I'd go to my graph. I'd put in here, delete anything else that's hanging around. I'd put in x squared minus 2x. And on the next line, 1 minus x over 2. I draw it. If it looked kind of like I was expecting, that'd be good. I can't really see all of it, so I'm going to change my window, press F3. I want to see more of my x-axis, I think. So let me go up to 5 on that, see if that helps. Okay, that looks more like it. Then if I want to find the x-coordinate, I'm looking for the intersection. So I press F5, graphically solve, F5 again for intersection. And here I'm given x equals minus 0.5, and I can scroll along. And here I'm given x equals 2. This is useful actually to find both coordinates because you're given x and y. Okay, write down an expression for the area enclosed by the graph of f, the line L, and the x-axis. So we've got our graph of f, which is this, our line L, which is this, and the x-axis. So the area that we're looking for is this bit here. That's the part that's got 3 boundaries. Above, we've got L, to the side here we've got F, and below we've got the x-axis. It does not include that little bit that's hanging on the bottom there. And that's going to make a difference when we try to write down this expression. So here I've got minus a half, some kind of key x points. Here I've got 0, and here I've got 2. So I know that if I integrate, I find the area from the function down to the x-axis. I'm going to split this up into 2 bits. There's a couple of ways I could do this. I could say everything underneath L, and then that's going to give me kind of this big triangle here, and then take away this bit. Or I could look at it as L minus F from minus half to 0, and then just F. I think I'm going to do that. I think I'm going to first of all concentrate on L, and I'm going to write it down not with the best notation to start with. So L, I will fill that in with its actual equation in a minute, but just while I'm getting my head around it, the integral from L from -½ up to 2, and then I'm going to subtract this bit, so that then I'm going to take away the integral from -½ up to 0 of f. Okay, that's not the only way to do it, but that's one way. So I can't leave this with L and f. I need to fill in the actual algebra there. So I'm going to say it's the integral from -½ to 2 of 1 minus x over 2 with respect to x, and then take off the integral from -½ to 0 of x squared minus 2x with respect to x. So this bit here corresponds to this bit here, which I don't want to count. So I'll have all of that bit there. So that's my expression, that's part C done. And then lastly, we need to find the value of this area. We'll use the calculator to do this. So I've got this drawn already. I'm going to go to graphically solve, scroll along. I want the integral. So I press those bits. I'm going to start with the integral of L. So I'll scroll up onto the red line, and I want to select my lower limit value. That's minus 0.5. And my upper limit value is 2. It's nice there, it shades it in. So I know here I've got 1.5625, and that's an exact number because it doesn't keep going anymore, and it's a triangle as well. And I'm going to take off the other bit, so I'll exit out of there, draw it again, graphically solve, integral, integral. This time, yes, I want what's underneath this function, so I'll select that one. My lower limit value again is minus 0.5. My upper limit is now 0. So I can see that part is shaded. That is 0.2916666. And then I just calculate that. It comes out as 1.27 when rounded to 3 significant figures, and I would put units squared because it's an area. And we're done.